Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today we're going to look at the same kind of thing that we looked at last time, but this time with the speed control and the bigger FET and the fast diode here. So what we have is 12 volts right now, and we're going to run this. The one battery is pretty charged, the other one's discharged. We've got the oscilloscope hooked up just on the drain. And what we're going to do is run 4 wires, 1 wire from each coil, into this little controller box here. So this is my small version of my controller. It's got the speed controller. It has circuit breaker, 40 amp circuit breaker here, and it's got temperature sensor on top of the MOSFET. Has a heat sink, but this does not have the water cooling. We're going to look at that in a moment. That can be added now. I have that as an option to buy the water cooler. I'm pretty much selling it for my cost price, so I'm not making any money off of that. In fact, I brought the price down on this particular kit to not very much above cost. So what we have here then is, out of the 32 wires, 4 motor coils here. Each one has 8 wires on it, and we're just going to run 4 of the wires out of the 32. That way we have one, each coil is firing. If I try to just run one coil, it's not as efficient as to run each coil. Now I have one generator coil shorted, and then the other one is running this LED over here like we looked at in the last video. Now what I found was, as I mentioned in the last year or so, these high speed ultra fast diodes here make a big difference in the output, and you can see the spike on there as well, the difference between the slower diode. So we have a good gate driver on here now. So what I have is, there are 2 forms of speed control, the pulse and the width, on this box here, and then we're just controlling the off time on the speed control here that will adjust the amperage, which I'll show in a minute. So now we're going to run this time with a Hall sensor here, because that's the way the speed control is sold right now. This is actually going to a customer. So I have my other opto timing board right here without the speed control. So I've just not hooked that up at all. And we'll run this, you'll see it speed up and start charging the batteries. Now we could get into running 24 volts, but not today probably. I have another battery here, we could probably do that. Now this thing doesn't have any cooling on it, because I figure this kit doesn't have the water cooling on it, and the customer can add that if they want to. So let's make sure our voltmeters So I was running for this for a little bit, and the batteries are stabilizing. Not quite stabilized yet, but getting there. So this is all ready to go. I just got to turn it on. Got an on and off switch here. And we've got an LED that will show us the pulse rate. And then the other thing is, I've mentioned this several times in my videos. So what we have here, well, I'll go over the details when I bring the camera closer later on here. But so I'm just going to position this. The top of the Hall switch is going to be triggered by a south pole. And what I want to do is go over the generator, or on the generator coil rather than the motor coil, because the motor coil will influence the pulses. Now in this case, I'm just running it. I could run it up here, but I actually didn't make this long enough to reach over here. So I'm going to run it underneath the bottom one right here. So if I want to turn it clockwise, I'll move it after top dead center. And at startup, well, you can adjust it a little bit as it gets up to speed. So let's give it a shot and see what's going on. Oh. Oh, yep. So you can see the amperage on this. So it's at about 8 amps right now. So you can hear it pulse, you can see the waveform. Now if I change the speed, or the pulse, so I bring it down, bring down the amps. So we can change the speed that way really easy. Here's the power level. I just got to position the Hall in the right spot too. Now one thing you can do for the vibration is put an elastic band around the outer ridge of the rotor. I did that with the small mini kit the other day and it worked just fine. So I think what I'll do is I'll get that for the rest of the kits for now. So you can see so it's relatively, it's only 90 degrees, room temperature is 83, so we're not really doing much to this. Now if I shorted out the generator coils, see it speeding up. The amp draw goes down and it speeds up real fast. Then I have another LED here. I do it with one hand. So anyway, I'm not really holding this in the best position. So that's that. Now I can add another battery here and see what happens. So what we're going to do is connect up turn it off first of all. And then what I'm going to do is just, actually I don't need to run that. I'm going to move this over . Okay, so that's going to be connected here. I think we can still see. So I'm going to just leave the other battery at 12 volts for now. And then I want to start this really carefully. Actually, what we're going to do. So initially, I'm going to run this at 12 volts. And then once I get it started, I'll move up 24 volts. I just don't have a heat sink on it, so I just want to be careful that I don't. I mean, I don't have a water cool on this, so. Now I can put this on. Just leave that light up there. Alright, so now we're going to run this. Now the next video, I was going to do it in this particular video, but I will wait for later this week on Saturday, I will run this with the water cooling with several MOSFETs. Now these are 2500 watt MOSFETs, so they can really put out a lot if you make sure they're kept cool. So what I'll have to do is move from this one to this one and this one to, oops, this one to this one. So we'll get it up to speed. And then what I'll do is I'll turn this down so that it doesn't draw too much. And then what I'll do is disconnect it, or wait, turn it down, change this over, okay, so now it's at 24 volts, but I tuned it down a little bit. So now I do have temperature sensor on here, just in case it does get too hot. Depending on where I put the Hall sensor, the speed will vary. So now I can adjust the speed. I'll come down now. So there's like 5 amps, 15 amps, 14 amps. I can just switch it down easily. And change the speed. You can see the switching is nice and clean. So now I want to bring the camera over so that you can see couple things here. What I was talking about. First of all, you can see LEDs. Okay, so here's the speed controller as it is. So first of all, you can see an on and off switch, 40 amp circuit breaker, LED, and so these are the wires that come out on the one side. The negative wire is the primary negative wire, and this is the coil wire on this side. And then I made the other side be the charging wire. And now really I'm running this is really for small kits and that, and I just decided to put the bigger MOSFET on it to show in this video and to give it to the customer like that. But anyway, that's why it's relatively small wire on here. When I show this kit with its controller, it will have a lot bigger wire. And like you can see here that I only have the 4 wires, one from each coil, right? So what we want to do is put probably 4 MOSFETs on this kit so that we can do 1,000 watts comfortably on each coil up to 48 volts. And then this is the diode that I have on it right now. It's right, actually it's inside, you don't see it. So I could have put this whole thing inside like I usually do with the smaller MOSFET, just like we do with our battery chargers. This is the case for the battery charger. But in this case I knew I was going to run it a lot hotter. So here's the Hall switch. Oh, if I can focus it. There you go. So that's the top, triggered by the south pole. So what else? So these were the generator coil I showed in the last video. This is 3 generator coils going in series to this LED over here. And this was just one. So you can see really in this video, this was as bright as the other one over there, so I could have run all 4 of them independently to produce the amount of light, but that wasn't really my point here. I wanted to show this thing really go fast, so I should disconnect. See, I don't have these hardwired at all, just so I think what I want to show now is the water cool system over here. So this is 1/2 of the 10 coiler with the trigger coil arrangement here. So you can see these are the output wires. And then this is for the water cooling. So essentially what I'm doing is using these aluminum heat sink and then using these aluminum heat sinks that I make up here. And so what we're going to do is now we're not going to be using these transistors in the kits anymore, because when we use the gate driver and the high speed gate driver and the high speed MOSFETs and the high speed ultra fast diodes, we get the same kind of spike as we do with the trigger coil, and there's a lot less circuitry involved. We don't have to use the boards anymore. So really, these are 200 watt devices, whereas those ones are 2500 watt, and it just makes sense to do that. So essentially what we're going to do is have 4 of those MOSFETs and then heat sink it onto one of these aluminum blocks here. And then this is a really neat pump and reservoir in one. It's got a little LED in it, and in fact I can show that running. Probably showed it in many other videos, but so this is just one that I had running at my last conventions. So then this is a little fan on this little radiator. So it blows through there, keeps that cool, and then it circulates the water. So this is an option. Now I am starting to get the double fan, double radiator, double the size, I mean. I'm going to start getting those as an option as well, especially for the bigger motors. So this 4-pole with 4 MOSFETs on it should be fine with just this arrangement right here, because I could really run it off of just 2 with the water cooling, but that will tend to create a lot more heat than the 4 would, and especially if someone's going to take it up to 48 volts and really crank this thing down. So that's it. You can use on this kit, like I said, you have the opto instead of the Hall sensor there. Oh, what was I getting at before was with these wires here. So these 2 wires are the negative connection of this wire is the same as this wire right here, but this is the wire that's important, that stays at 12 volts, because the whole driver system in there is based on 12 volts and the gate of the MOSFET as well. So if we, like we did right here, when I went up to 24 volts, I used, let's turn this on. I ran this at 12 volts. It's in reference to the furthest most negative terminal. And so we don't want to have it there because it would be 24 volts in that case, because we're running this wire through there. So anyway, what we'll show in the next video is this MOSFET here driving the bigger batteries. A typical system for this I'll show with the golf cart batteries. These are only 35 amp hour batteries. So then what we'll have is 12, 24, 36, and 48 volts with the 4 MOSFETs on there. And then I'll do the water cooling, because the water cooling will be provided with the assembled kit. The unassembled kit will be everything but the water cooling. It will still have the heat sink, but I won't include that. with the unassembled kit, because it's going to go over my cost price. So so then you'll have the speed control on there as well, and that's important so that you can adjust that. Now what I won't have is the circuit breakers on there. That's something for people to, I'll have the thermal switches so that if the MOSFET heatsink gets hot, it will switch off. But I won't put a circuit breaker in there because right now the 40 amp comes in that size, and after that when you start going up to the 100 amp circuit breakers, they're pretty pricey, and you know, if you want that, then it's going to cost more. But I figure people will have their own circuit breakers, and that really relates to how fast you want them to switch on. That's one thing that you have to consider. You don't really want a fast turning on circuit breaker. You want a slow one, because the pulses will tend to trip, just like a GFI plug. They trip real easy. They're not slow. They're there for your safety. This isn't so important. If you were to blow out something, you would have time. You could wait a whole second at least before, and even more, you could probably wait 30 seconds before it would start melting things down. But I think what I'm trying to say is, also with the circuit breaker, is it may be better to run each individual circuit breaker between each MOSFET on the negative terminal, and that way so you can see the temperature there, 100 degrees. Heatsink isn't really that hot. But anyway, the idea of putting one master circuit breaker in, the problem with that is if you were to blow only one MOSFET, it may, like, you may only partially blow it or something, and it may not push the amperage above the circuit breaker level. And also you're going to have different circuit breakers for different voltages, no doubt. So so that's why it may be wiser to have individual breakers per line. And I think that's it. But we do have, like I said, the thermal protection on here. So this one is at 100 100 Celsius, or 100 Fahrenheit, or is it? It's 100. It's not 100 Fahrenheit, I don't think. I mean, not 100 Celsius. Anyway, I forget what it is, but anyway, I use that on my chargers. So I think that's it. The next video will have more details. You'll see the final system. Thank you for watching.